In this video, we are going to continue looking at colligative properties, but explore what happens to the freezing point of a solution when you add a solute. The freezing point depression is what happens when you mix a solute with a liquid. The freezing point will be lowered. This is why salt is a lot of times added to sidewalks or roads because it will lower the freezing point of the water. And what it looks like to us is that water or ice will melt. We can also calculate the freezing point depression by using the equation delta TF is equal to Kf times molality. So this looks very similar to the boiling point elevation mathematical equation. Every solvent will have a Kf value that is specific to that solvent. Commercial dynamite is very, just not very safe, and you don't really want to ship it. If you add a solute, it can lower the freezing point of that commercial dynamite and make it safer to travel. So let's look at an example of how the freezing point will be depressed or the freezing point will be lowered in the presence of a solute. We are dealing with KCN. I know that KCN is soluble in water because it's a group 1 metal. So this is going to have two particles. When I go through and calculate the freezing point depression for this, we will take the molarity of the molality of the solution and multiply it by the Kf. So the Kf value for water is 1.86 degrees Celsius per molal. And we can multiply that by the molality, which is 1.38. And we have two particles present. So when we do that math, I'm going to take the 1.86 and multiply it by 1.38 times 2. And I get 5.13 degrees Celsius. This answer does not make sense for the freezing point. It does make sense for the change in the freezing point, which is delta TF. So I need to calculate my freezing point. The normal freezing point of water is 0 degrees Celsius. So I need to subtract my delta TF from the normal freezing point of water in order to see what my new freezing point is. So this is going to be negative 5.13 degrees Celsius. This is a freezing point depression. The temperature is going to be lowered. 5.13 tells me that the temperature has increased from the normal freezing point. So that can't be my answer. And that's why I have to subtract it from my normal freezing point.